Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying proportional and non-proportional functions. This is standard 8.5H in the great state of Texas, and we are using item number 30 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have 4 different problem situations. They're very basic here. And we're looking for the one that does not represent a proportional relationship. All right, well, that's the only clue we're going to get is proportional relationship. And that doesn't really help us define it. And it's not on your mathematics chart. So we need to make sure we understand what proportional and non-proportional relationships or non-proportional functions actually mean. So when we're dealing with proportional, well, it could be a proportion. And that means that we are using this, which is on your mathematics chart, direct variation. So we call something direct variation when it's in the form of this, y equals kx. And so you have just your basic variables, y and x, and the only thing that's different about them is x is being multiplied by k. So if you wanted to, you can actually solve these problems using y equals kx. Or you can actually use proportions, right? You can do y over x equals ky over kx. So all the proportions we learned in 7th grade work here with these types of problems because it's proportional. But we get the non-proportional. So that's the one we're looking for, the one that's not proportional. It's going to look similar. But instead of direct variation, it actually takes a form called the slope-intercept form, which we've been doing a lot of work with this year in 8th grade. So it starts similar, y equals mx. So this k and this m, they both represent the slope, so that looks similar. They just replaced the k with the m, but they both mean the same thing. But you get a plus b. So there's always a little something extra on the end, either a plus or minus, but we just represent with a plus b. So you cannot do a proportion here because you've got this little extra spice at the end there. So the difference here is if x equals 0, well, if x equals 0, right, then y equals 0. If it's proportional, which means it goes through the origin. But if x equals 0 for non-proportional, y would equal b. That's our y-intercept. So you see that's where the difference is right there. If x is equal to 0, you see the difference. This one does not go through the origin. So we're looking for something that looks more like this, the y equals mx plus b slope-intercept form, than direct variation. So now that we know what we're looking for, let's get into the actual problems. The number of gallons of water in X barrels with 42 gallons of water in each barrel. Okay, so the number of gallons of water, so that's just going to be our dependent variable. It's X barrels, and then we're multiplying it by 42. So 42 gallons in each barrel times X. Now that's your direct variation. The amount of an employee makes, who makes $8.50 an hour in H hours. Okay, so the amount, so we're looking for Y again. This time it's H hours, and then the rate is going to be 8.5. So it looks like it's that same form, y equals kx. The weight in X weeks of a puppy, so the weight of a puppy, y, X weeks, gains 2 pounds per week, all right. If its starting weight is 8 pounds, I think that's what we're looking for. Right here, if its starting weight is 8 pounds, that's giving you a little extra on the end there. Let's check J to make sure it doesn't work. The cost of purchasing, so the cost is Y, P pounds. If you've got 0.55 pounds per banana there, pounds. And so you're going to notice that 0.55 P is all of these are doing that y equals kx, that direct variation. But if you have a starting weight, if you have an additional cost, an initial fee, startup fee, that's going to be h.